All right, number 14, the area of this pentagon will be 5 of the red triangles, where each triangle is 1/2 times the base times the height, where the base is the distance, which they told us is 10. So 5 triangles, where each triangle is 1/2 times a base of 10, and then we just need the height. So the height is this dashed segment A. It's the height of our red triangle. So a full revolution is 360. We divide by the 1, 2, 3, 4, 5 central angles. Each central angle is 72. So when we cut it in half, we get 36. In our green right triangle then, to find this height that we need, which needs to go right there, we can do tangent of 54 is the opposite side divided by the adjacent side. And therefore, 5 times tangent of 54 degrees is A. That's our height. That's all we needed, and now we're done. So remember, there's no distributing. You just multiply from left to right, or really any order. So 5 times 10 is 50. 50 times a half is 25, and 25 times 5 is 125. This is the exact answer, and this is the decimal approximation rounded to the nearest hundredth place. Item number 16, we're dealing with an octagon, which has 8 sides. So the area of the octagon will be the area of 8 triangles, where each triangle is 1/2 times base times height. So the base of each triangle is the side length, 8. So the area of our octagon is 8 triangles. Each triangle's area is 1/2 times the base of 8 times the height. So now we just need to know the height, which is the height of this triangle here. It's perpendicular to the base. Let's call it A. We need to know how many degrees these angles are so we can find A using SOHCAHTOA. So you can see there's these central angles, and there's 8 of them. So a full revolution divided by 8, each central angle is 45 degrees. 45, 45, 45, 45, 45, 45. But it cut in half, so each of these angles is 45 divided by 2, which is 22.5. That's the measure of this acute angle of our right half of this triangle. We'll say the green half, the right triangle in which we'll use SOHCAHTOA. Since the side length is 8, the green triangle's side length will be 4. And now we can use SOHCAHTOA. Well, we need 8 and we know 4. A is what we need, and we know 4. We also know that this angle here is 22.5 degrees. So if we stayed at that angle, which trig ratio uses 4 and A? Opposite and adjacent. That would be a tangent ratio. So the tangent ratio of 22.5 degrees is the opposite side divided by the adjacent side. And therefore, the adjacent side, A, will equal 4 divided by a tangent of 22.5 degrees, which is about 9.656854. All right, we can finish our problem then. The area of this octagon is the area of 8 triangles, where every triangle has an area of 1/2 times base times height. And that is approximately 309.02 square centimeters.